Good morning students, welcome back to Share the Maths channel, and this is the continuation video of the Eamcet coaching classes matrices video number 4. Okay, before starting the problems, let us discuss about some definitions. Okay, so the first definition is cofactor of a matrix and the next one minor of a matrix. Okay, what are cofactor and what are minor of a matrix? Suppose first I am taking one matrix A here, so this is equals to A, B, C, D, E, F, G, H, I. Okay, suppose here I take one matrix like that, A, B, C, D, E, F, G, H, I. So what is the minor of the matrix? Minor of the element of a matrix. So first suppose I take the first element. Okay, suppose I take here the first element. Now I want the minor of that element. Now how to find the minor value? Simply see here, minor of A is equals to, simply first remove the row and column in which this element present. Just remove this row and this column in which the element A is present. Now take the remaining values. What are the remaining elements? E, F, H, I. Okay, just simply you have to take the determinant to this matrix to get the minor of the element, that is E, I minus H, F. So this is nothing but the minor of the element here. Okay, this is the procedure to calculate the minor of an element. So how to take the minor value? Suppose if you want the minor of this element, just leave the row and column in which that element is present. Now taking the remaining 4 values and doing the determinant of the remaining 4 values. Okay, example, I am taking one example here in terms of the numbers here, that is, if suppose A is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, suppose this is the given matrix. If you want to take the minor of this element, minor of the 8, okay, just leave the row and column in which this element present. Just leave these two and take the remaining 4 elements, that is 1, 3, 4, 6. Now finding the det of this value, that is 6 minus 12 is equal to minus 6. Okay, this is the minor value. And what is the cofactor of an element? Cofactor is nothing but this is equals to minus 1 power I plus j into minor of the element. Simply we have to multiply the minor element by the value minus 1 whole power I plus j. What are I comma j here? I is nothing but the row number and j is nothing but the column number in which this element A present. Okay, so this is nothing but the minus 1 whole power I plus j of the minor of the A. Okay, suppose if you want to take the minor of this element, that is cofactor of 8 here, if you want to take the cofactor of this element 8 here, then how to take that value? Minus 1 whole power I plus j. What is I here? Row number, that is here the element 8 present in the third row, that is 3 plus, and the element 8 present in the second column, that is 3 plus 2. Simply here you have to take that I plus j, here I comma j are nothing but the row number and column number, okay, into minor of the element. What is the minor of the element? Here we have minus 6. And what is this? Minus 1 whole power 5 into minus 6. What is minus 1 whole power 5 value? Minus 1 into minus 6. Therefore, the answer is equal to 6. Okay. So, this is the procedure to find the cofactor of the element, and this is the minor of an element. Now, the next one, singular matrix. What is the meaning of the singular matrix? If det A is equal to 0, determinant of the matrix is equal to 0, then the matrix is said to be the singular matrix. And if det A is not equals to 0, then the matrix A is said to be the non-singular matrix. Okay. And what is A inverse formula? Okay, listen. If suppose here we have the matrix A is equal to A, B, C, D. Here means it is a 2 by 2 matrix. Then the formula for A inverse is equal to 1 by AD minus BC into D minus B minus CA. Okay. This is the formula for finding the A inverse value to the 2 by 2 matrix. Now how to find the inverse to the 3 by 3 matrix? For the 3 by 3 matrix, the formula is here. A inverse is equal to adjoint A by det A. Okay. The most important concept this is A inverse is equal to adjoint A by det A. This is the formula to find the A inverse to the 3 by 3 matrix. Now what is det A? Simply we have to take the determinant value. And what is adjoint A? How to find the adjoint value? Okay, see here. I am finding the adjoint here. Suppose A is equal to, here we have one matrix 1 2 3 2 3 1 3 1 2. Okay, suppose here we have the matrix like that 1 2 3 2 3 1 3 1 2. Now I want the adjoint A value. Okay, suppose if you want to find the adjoint A value, then how to take that value? Okay, see here. So first here I am finding the cofactor matrix of this matrix, cofactor matrix. The actual definition is simply we have to replace each and every element by its cofactor, then we will get the cofactor matrix. But here without finding the all the elements cofactors, I am using some shortcut method here to find the cofactor matrix. Here I am finding the cofactor matrix by applying the shortcut method. Okay, see all of you what is the shortcut. So first to take the second row here. Okay, first I am taking the second row elements in the order middle one, last one, first one, again middle one. Okay, that is middle one 3, last one 1, first one 2, again middle one. First I am taking the middle row values, second row elements. Okay, in the order middle one, last one, first one, again middle one. Now I take the last row elements, that is middle one 1, last one 2, first one 3, again middle one, that is 1. Okay, next I am taking the first row elements, that is middle one, last one, first one, middle one. Again I am taking the second row elements in the same order, middle one, last one, first one, middle one. Okay, understand all of you? This is the very easiest shortcut method to find the cofactor matrix here. So this is equals to, we have to take the elements in the order second row, last row, first row, again second row, and in the order middle one, last one, first one, again middle. Okay, now just doing the det values here to all these values, just I am taking the 2 by 2 matrix values here and finding the det values. Okay, see here, first one 3 2s are 6 minus 1, next one 3 1s are 3 minus 4, next one 2 1s are 2 minus 9. Okay, and here 3 minus 4, finding the det values here, AD minus BC, 2 into 1, 2 minus 3 into 3, 9, 2 minus 9, and the next one 6 minus 1, and the next one 2 minus 9, and the next one 6 minus 1, and the next one 3 minus 4. Okay, so this is equals to the answer of the cofactor. The answer of the cofactor matrix is here 5 minus 1 minus 7 minus 1 minus 7 5 minus 7 5 minus 1. Okay, this is the answer of the cofactor matrix here. Now what is adjoint A? So here the adjoint A is nothing but the cofactor matrix whole transpose. This is nothing but cofactor matrix whole transpose. What is the meaning of the transpose? Simply we have to write the first row as the first column, that is 5 minus 1 minus 7, second row as the second column, minus 1 minus 7 5, and third row as the third column, minus 7 5 minus 1. Okay, this is the cofactor matrix and this is the procedure to calculate the cofactor matrix. Okay, and what is the procedure to find the det value? Okay, see here, det A is equal to 1 2 3 2 3 1 3 1 2. This is the most important concept of the IP paper. Very easy procedure. How to find the determinant? First we are taking the first value here. We are using the first row elements here to find the determinant. First I am taking the first element. Now leave these two. Now taking the det of these four, 6 minus 1. Okay, now at the middle number you have to take the minus sign. Okay, minus second number. Now leave these two, row column. What are the remaining elements? 2 1 3 2. Now finding the det value 4 minus 3. Okay, this is 4 minus 3. Now place 3 off. Now writing the third number. Now leave these two, row column. Okay, now taking the 4 values and finding the det value. 2 into 1 2 minus 3 into 3 9, that is 2 minus 9. Okay, so this is 5 minus 2 minus 7 into 3 minus 21. So this is equal to 3 minus 21 is equal to minus 18. Therefore this is the procedure to find the determinant value. and this is the procedure to find the cofactor matrix. Okay, and from the cofactor matrix we have to take the adjoint value. Adjoint is equal to cofactor matrix whole transpose. So now we will solve the questions which are related to this topic. Okay, let us start the problems. Okay, so the first problem, if A is equal to ABC, BCA, CAB, then what is the cofactor of the A21? What is the meaning of the A21? This is the element in the second row and first column. Okay, so what is the element of the second row and first column? Here we have that A21 is equal to B. Second row, first column, that is the element is B here. We have to find the cofactor to this one. Now what is the cofactor formula? Cofactor is equal to formula minus 1 whole power I plus j into minor value. Now what are I comma j? I is equal to row number, that is 2. J is equal to column number, that is 1, into minor value. Okay, this is the formula. So this is minus 1 whole cube into what is minor value? Leave the row and column. Simply leave the row and column in which the element B present. Now taking the remaining 4 elements B, C, A, B. Okay. Now minus 1 power 3 is equal to minus 1 into this is B square minus AC. Therefore the answer is AC minus B square. That's all. That is the answer and that is the first option. Okay. See the next one. If A is equal to 1 square, 2 square, 3 square, 2 square, 3 square, 4 square, 3 square, 4 square, 5 square, then what is the minor of the element A22? What is A22? A22 means this is the element that present in the second row and second column. That is, this is equals to A22. Okay. Second row, second column. That is the element A22 is equals to 9 here. Now we want the minor of this element. So how to take the minor value? Minor of A22 is equals to, just leave the row and column in which this element present. Just leave the second row, second column, and taking the remaining 4 values 1 square, 3 square, 3 square, 5 square. Okay, is equals to 19925. So this is equals to 25 minus 81 and that is equals to minus 56. That's all. This is the answer and that is the first option. Okay, this is the procedure to find the minor value. Just simply leaving the row and column in which the element present and simply taking the det of the remaining values. But what is cofactor? Finding the minor value, and before minor value we have to take the value minus 1 power I plus j. What are I comma j? Row number and column number. Okay. Now this is the next problem. If A is equal to ACB, BAC, CBA, then what is the cofactor of the element A32 in the matrix A plus A transpose? We want the cofactor of this element in the matrix A plus A transpose. Okay, see the answer. So first I am finding the value A plus A transpose. I am finding the A plus A transpose matrix is equals to, what is A matrix? Here we have ACB, BAC, CBA. So this is A matrix. And what is A transpose value? Transpose means I am taking the first row as the first column here. So this is first column ACB and second row as the second column BAC and the third row as the third column CBA, and this is equals to, now adding the elements A plus A is equal to 2A, next one B plus C, next one B plus C, and coming to the second row, this is B plus C, this is 2A, this is B plus C, and the third row, this is B plus C, this is B plus C, this is 2A. Okay, this is the matrix A plus A transpose. But what is the given question here? We want the cofactor of the A32. A32 means third row, second column. That is, we want the cofactor of this element. Okay, this is nothing but the A32 element, B plus C. Therefore, A32 is equal to here B plus C. Now we want the cofactor of this element. Therefore, cofactor is equal to minus 1 whole power 3 plus 2. Row number is equal to 3 and column number is equal to 2. Okay, minus 1 power 3 plus 2 into, okay, leave the row and column in which this element present. Now writing the remaining values 2A, B plus C, b plus c, b plus c. Okay, just leave these two and writing the remaining 4 values is equals to minus 1 whole power 5 is equal to minus 1, and this is 2a of b plus c minus b plus c into b plus c is equal to b plus c whole square. That's all. This is the answer, and that is the first option. Okay. Okay, so the next one, if a is equal to ab0 cd0 0 0 1 where ad minus bc not equal to 0, then what is a inverse value? Okay, we want the a inverse. So what is a inverse formula? A inverse is equal to adjoint a by det a. That is, we want the adjoint a value and det a value. What is det a? Finding the determinant. What is the det value here? Okay, see here in the last row we have the element 0 0 1. That is, it is enough to find the det to this number, that is 1 into what is the det value? AD minus BC. That is the det A is equal to here AD minus BC. Now we want the adjoint A. So before finding the adjoint A, first I am taking the cofactor matrix, since adjoint A is nothing but the cofactor matrix whole transpose. So to get the adjoint A, first we want the cofactor matrix. What is cofactor matrix? Already at the starting I explained the shortcut method how to find the cofactor matrix here. Okay, see here. First we have to take the second row elements. What is second row element? CD0. Now how to take the elements here? In which order? Middle, last, first, middle. That is D0CD. Okay. Middle, last, first, middle. Now taking the last row elements in the same order 0, 1, 0, 0. Middle, last, first, middle. Now writing the first row elements in the same order B0 AB, and coming to the last row again second row elements, that is D0 CD. Okay, now finding this value. What is this value? How to take the simplification? D into 1, D minus 0, that is D, 0 minus C, that is minus C, 0 minus 0, that is 0, 0 minus 0, that is 0, A minus 0, that is A, 0 minus 0, that is 0, 0 minus 0, that is 0, 0 minus 0, that is 0, AD minus BC. Okay, so this is the cofactor matrix. Now what is adjoint A? Adjoint A is nothing but the cofactor matrix whole transpose, that is equals to, now take the first row as the first column, which is D minus 0, and second row as the second column. So this is 0 minus B, A minus 0, 0, 0 minus 0, 0, 0 minus 0, 0, 0 minus 0, 0, AD minus BC. Okay, this is the cofactor matrix. But what is adjoint A? This is nothing but the cofactor matrix whole transpose. Okay, that is, so try taking the first row as the first column, and second row as the second column, and third row as the third column. So this is 0, 0, AD minus BC. So this is the adjoint A value. Therefore, A inverse is equal to adjoint A by det A, 1 by det A into adjoint A. Therefore, the answer is 1 by, what is det A value? AD minus BC. What is adjoint A? D minus B0 minus C is 0, 0, 0, AD minus BC. That's all. This is the answer, and that is nothing but the second option. Okay. Okay, see the next question. If A is equal to 1, 4, 2, 8 and B is equal to x, y, y, x, then what is the cofactor of A to 1 in the matrix AB? What is the cofactor of the A to 1 in the matrix AB? That is, first we want the AB matrix, and in that AB matrix we will take the cofactor of A to 1. Okay. So first I am finding the AB matrix. AB is equal to A into B. So this is equal to multiplying the two matrices. First row by the first column x plus 4y. First row by the second column y plus 4x. Second row by the first column 2x plus 8y. And second row by the second column 2y plus 8x. Okay, this is the matrix. Okay, this is the matrix. Now what is the given question? Cofactor of A to 1. What is A to 1 here? So this is the A to 1 element, that is second row first column, element of the second row first column. Now we want the cofactor of this one, that is just leave these two, and here we apply the signs like that. So this is equals to, therefore cofactor is equals to formula minus 1 whole power 2 plus 1. Cofactor means here we have to take the minus 1 power 2 plus 1 I plus j into, now leave the row and column. Now write the remaining value. What is the remaining value? Here we have y plus 4x, and minus 1 power 2 plus 1 is equal to minus 1. So this is minus of 5 plus 4x, which is equals to minus 1 minus 4x, and that is the first option. Okay. Okay, so the next question, problem number 6. Det of the matrix 18, 40, 18 and 40, 18 and 198, 18 and 198, 440. We have to find the det of this matrix. Okay, I am writing the question here. Determinant of 18, 40, 89, 40, 89, 198 and 89, 198, 440. Okay, this is the given question. But when we find the det value directly to this question, then it will be very complicated since the numbers are very large in this question. Okay, so without finding directly the determinant value, I am taking one shortcut here. That is, first I am taking the simplified numbers of this determinant. I am taking the simplification of the elements here. Now how to take the simplification? By applying the elementary row operations. That is here. Okay, see here. I see the second row here, 40, 18 and 198. Now if suppose if you multiply this number by the two number, then what you get? 36. 40, 36, the two numbers are very close to each other. That is, when we subtract the two numbers, we will get the very less number. Okay, if you multiply this number by the number 2, then you get the 36. 40 minus 36, when we subtract the two numbers, then you will get the very small number. That is, I am making the transformation as here. I am changing the second row elements as here, r2 minus 2r1. That is, I am replacing all the elements of the second row by this transformation. That is, here I am placing the element 40 minus 2 into 18. 40 minus 2 into 18 is equal to 40 minus 36 is equal to 4 here. Okay, in the same manner here also I am making the same transformation to the third row also. Okay, this is 40. I am multiplying this number by the number 2, then it becomes 80. 89 minus 80 is equal to 9. That is, I am making the numbers as the small numbers here. So applying the same condition, that is, what is the condition here? R3 minus 2R2 means I am multiplying the second row by the number 2 and I am subtracting this number by the number 3. Okay, so after applying these two transformations, what will be this one? How to convert this one? Okay, see here, I am writing the first row here without changing the values as it is. That is 18, 40, 89. Okay, see here, 40 minus 36, that is equals to 4. 89 minus 80, that is equals to 9. 198 minus this is 178. 198 minus 178. 2 into 89, 178. 198 minus 178, that is equals to 20. Okay, and here also for 89 minus 80, that is equals to 9. So this is 178. 198 minus 178, that becomes 20. And this is, when you multiply this number by the 2, then what you get? 396. Okay, so 440 minus 396 is equal to 44. Okay, that is, here the numbers are become some small numbers, becomes here some small numbers when compared to the given question. The numbers becomes the small numbers here when compared to the given question. Okay, now see here, again I am applying this type of transformations again. Okay, see here, this is 18, this is 4. If you multiply this number by the 4, then what you get? 16. 18 minus 16 is equal to 2. Okay, again I am multiplying this number by the number 4, and see here, this is 9, and I multiply this number by the 8. 9 minus 8 becomes 1. Okay, so see here, I am doing that. R1 gives to R1 minus 4R2. R1 gives to R1 minus 4R2. That is, simply multiply this row by the number 4 and subtract that row from the first row. That is 18 minus 16. 40 minus 36. 89 minus 80. Okay, and the next condition, R3 gives to, now here how to take the transformation? Multiply this number by the 2. 2 4s are 8. 9 minus 8, 1. That is R3 minus 2R1. Okay, that is R3 minus 2R2. That is, simply here I am taking the simplification of the numbers. I am changing the given numbers as a small numbers. Okay, so see here, 18 minus 16, 2. and this 40 minus 36 4, and this 89 minus 89, okay, and this is 4 9 20, and see here 9 minus 8 1, and this is 20 minus 18, that is 2, and this 44 minus 40, that is 4. Now I am finding the dead to this one, okay. So this is 36 minus 40 minus 4 minus 4 of 16 minus 20 minus 4 plus 9 of 8 minus 9, that is minus 1, okay. Minus 8 plus 16 minus 9. Therefore, the answer is equals to minus 1. That's all. This is the answer. When we take the numbers, when you change the numbers as the small numbers, then you will easily get the determinant value, okay. This is the procedure. This is a shortcut method to find the determinant value very easily without finding the big calculations here, making the numbers as the small numbers and doing the determinant value to get the answer. Understand all of you? Okay, so the next one, determinant of the ABC, BCA, CAB is equals to, very easy question, direct type question. Directly we can tell the answer. This is a very easy calculation. So finding the dead value directly, dead of ABC, BCA, CAB is equal to, how to find the dead value? A into, leaving these two values here. So this is BC minus A square minus B of B square minus AC plus C of AB minus C square, okay. Therefore, this is equals to ABC minus AQ minus PQ plus ABC plus ABC minus CQ. Therefore, the answer is equals to ABC plus ABC plus ABC is equal to 3ABC minus AQ minus PQ minus CQ. Directly finding the determinant value, very easy question. Therefore, the answer is equal to third option, okay. Okay, see the next one. If A comma B comma C are all positive numbers but not all equal, then what is the value of the determinant dead of ABC, BCA, CAB? What is that value? Here the options are given like that: 0, less than 0, greater than 0, cannot be determined. Okay, already in the last question, already just now we find this determinant value. So what is the answer of this determinant? So this is equal to, the answer is equal to here 3ABC minus AQ minus BQ minus AQ. Okay, so this is nothing but 3ABC minus of AQ plus BQ plus AQ. Now we have to find this value which it returns, whether it returns the positive value or negative value or equals to 0, whatever it is, okay. So we have to find that result. So first I am replacing some values here. If suppose A is equal to 1, B is equal to 2, C is equal to 3, in this one, in this condition I am replacing the values like that. ABC values are 1, 2, 3. So this is 3 into 1 into 2 into 3 minus of 1 cube is equal to 1, 2 cube is equal to 8, 3 cube is equal to 27. So 9 2s are 18 minus 28, 36. 18 minus 36 is equals to minus 18, which is the negative number. That is, this condition holds for all values of ABC which are not equal. Therefore, the answer is less than 0. The determinant value is less than 0. In general, without finding this answer directly, we can tell the answer in which method, in which we can tell the answer here 3ABC. When we take the product of these three numbers, that is always less than always this is less than the number AQ plus BQ plus AQ. Already we know that the value of the AQ plus BQ plus AQ is always greater than the value of the 3 into ABC. Directly by seeing that condition, directly you can tell that answer, okay. So when we check the value, then what we get the number that is less than 0. So answer is less than 0. That is the second option, okay. Now the next one. Det of 1a square, 1b b square, 1c c square is equals to, how to find the det value? Actually, this is the essay question in intermediate, very important essay question. But here I am solving this question in shortcut method just by taking the verifications by replacing some values in place of ABC. Very easy concept. Okay, listen. So in this question, to find the det value, this is the question. 1a square, 1b b square, 1c c square. I am taking the values as I am replacing some values in place of ABC here. That is here I am taking that A is equal to 1, B is equal to 2, C is equal to 3. Okay. So here in this one, I am replacing the values like that. A is equal to 1, B is equal to 2, C is equal to 3. So what will be this one now? 1, 1, 1, 1, 2, 4, 1, 3, 9. Okay. C is equal to 3, then C square is equal to 9. B is equal to 2, then B square is equal to 4. Now what is the dead value? 18 minus 12, 6 minus 1 of 9 minus 4, 1. 5 plus 1 of 3 minus 2, 1. So this 7 minus 5 is equal to 2. So answer is equal to 2 here. Now checking AB, so this is not the correct answer. Here 0 means answer is equal to, so this is not the correct answer. And A into B into C, 1 into 2 into 3, this is equal to 6. But answer is equal to 2. So this is also not the correct answer. Now checking which answer is right among these two. Okay. Now replacing that ABC values here. So in this one, this is 1 plus 2, 3. 2 plus 3, 5. 3 plus 1, 4. So this is equal to 60. No, this is not the correct answer. Now replacing the values here. 1 minus 2, minus 1. 2 minus 3, minus 1. 3 minus 1, 2. Yes, this is equal to 2. So this is the correct answer. Without finding the determinant value, directly we can tell the answer. Just simply replacing ABC values, some values in the quotient, and find the determinant value, and replacing the same values in the given options, and just checking the values at which this answer tallies with the option. So this is the procedure. Okay. Okay, so the next one, 1, 1, 1, x, y, z, x cube, y cube, z cube. So find the dead value. Same procedure. Again here also I am taking the verifications. Okay, see here, 1, 1, 1, x, y, z, x cube, y cube, z cube. So here also I am replacing the values like that. X is equal to 1, y is equal to 2, z is equal to 3. So what will be the determinant value now? 1, 1, 1, 1, 2, 3. This 1 cube is equals to 1. 2 cube is equals to 8, 3 cube is equal to 27. Okay, and this is 54 minus 24, 30 minus 1 into 27 minus 3, 24 plus 8 into 1 into 8 minus 2, 6. So this is equals to 6 plus 6 is equal to 12. Therefore determinant value is equal to 12. Okay, now check the options. 1 plus 2 plus 3, 6 into 1 plus 2, 3 into y plus z, 5 into 3 plus 1, 4. So this is 12 into 6, 72 into 5, which is not equals to 12. So this is not the correct option. Now check this one. 1 plus 2 plus 3, 6 into 1 minus 2, minus 1, 2 minus 3, minus 1, 2, 3 minus 1, 2. So yes, this is equal to 12. So this is the correct option. Replacing the values, x, y, z values in the options, and checking the answer in which option this answer tallies with the answer. Therefore 12 is equal to 12 means second option is the correct answer. Okay. Okay, so the next question. Here also we have to find the determinant value. So the question is b square plus c square, a square, b square, c square plus a square, b square, c square, c square, a square plus b square. Here I am not taking the, this is also a verification processor, but here I am not taking the values 1, 2, 3. Here I prefer the values 1, 1, 2. Since when we take the numbers 1, 2, 3, then the numbers will be big numbers here. 2 square plus 3 square, 9 plus 4, 13. So for the purpose of making the small numbers, for the only the purpose of the making the small numbers, here I am using the numbers as 1, 1, 2. Okay. Okay, replacing the values. B square plus c square, that is equals to 5. A square 1, a square 1, b square 1, c square plus a square 4 plus 1, 5, b square 1, c square 4, c square 4, a square plus b square 2. Okay, now doing the dead value. 5 of 10 minus 4, 6, minus 1 of 2 minus 4 minus 2 plus 1 of 4 minus 20. 4 minus 20 is equal to minus 16. So this is 30 plus 2. 32 minus 16 is equal to 32. So answer is equal to 32. Now checking the options here. So this is 1 square, 1 square, 2 square, 1 into 1 into 4, which is not equals to 32. This is 4 into 1 into 1 into 2, which is not equals to 32. And this is 4 into 1 into 1 into 32 minus 16 is equal to 16 here. Not 32. 32 minus 16 equals 16. Okay, this not equals to 8. 8 is not equal to 16. 4 this not equal to 16. This 4 into 4, 16. Yes, this is the correct answer. And here 2 into 1 into 1 into 4, this is not equals to 16. Therefore, the correct option is only 4a square b square c square, and that is equal to 16. So, that is the correct option. Option 3 is the correct option. Okay. Okay, see the next one. Same procedure, finding the dead value, taking the verifications. So here also I am taking that the values as a is equals to 1, b is equal to 1, c is equal to 2. Okay, so this is 1 minus 1 minus 2, that is minus 2. This is 2, this is 2, and this is 2, and this is 1 minus 2 minus 1, that is minus 2, and this is 2, 2c 4, 2c 4, 2 minus 1 minus 1 0. Okay, now finding the dead value. Minus 2 of 0 minus 8 minus 8, minus 2 of 0 minus 8 minus 8, plus 2 of 8 plus 8 16. So this is 16 plus 16 plus 32. 32 plus 32 is equal to 64. Therefore the answer is equal to 64. Now checking the options one by one. This is 2 of 1 plus 1 plus 2, that is 4 cube. 4 cube is equal to 64 into 2 128. So this is not the correct option. A minus b minus c. 1 minus 1 minus 2. Minus 2 whole cube is equal to minus 8. So this is not the correct option. And 2 of minus 8, that is equal to minus 16. This is not the correct option. So this a plus b plus c whole cube. 1 plus 1 plus 2 whole cube. 4 cube is equal to 64. Yes, this is the correct option. Okay. When we have the terms a, b, c, a minus b minus c, a square, b square, c square in type of these questions, just simply replace the values 1, 1, 2 to get the answer very easily. Okay. Okay, see the next one. 2c, 2c, c minus a minus b, a minus b minus c, 2a, 2a, 2b, b minus c minus c, 2b. Same procedure, I am replacing that a is equal to 1, b is equal to 1, c is equal to 2. Okay, see here. 2c, 4, 2c, 4. This is 2 minus 1 minus 1, 0. A minus b minus c, 1 minus 1 minus 2, minus 2. 2a, 2, 2a, 2, 2b, 2. This 1 minus 1 minus 2 means minus 2, 2b, 2. Okay, now finding the dead value. 4 of that is equals to 4 into 4 plus 4, 8 minus 4 of minus 4 minus 4, minus 8. So this 32 plus 32 is equal to 64. Therefore the options are 1 plus 1 plus 2, that is 4 square is equal to 16. 1 plus 1 plus 2, that is 4 cube is equal to 64. Yes, this is the correct answer. So answer is the second option. Okay. Okay, so the next question. 1 plus a 1 1 1 1 plus b 1 1 1 1 plus c. Finding the dead value. Same procedure, replacing the values. A is equal to 1, b is equal to 1, c is equal to 2. So the dead becomes 1 plus 1, 2 1 1, 1 2 1. This is 1 1, 2 plus 1 3. Okay. And this is equal to 2 into 6 minus 1 5, minus 1 into 3 minus 1 2. Plus 1 into 1 minus 2 minus 1. So this is 10 minus 2 minus 1. 10 minus 3 is equal to 7 answer. Okay. So this is not the correct answer. This is not the correct answer. 1 into 1 into 2 is equal to 2. So this is not the correct answer. Now what is this value? 2 into 1 plus 1 plus 1 plus 1 by 2. Okay. So this is 2 into 3 plus 1 by 2. So this is 2 into 7 by 2. Yes, this is the correct answer. Okay. Okay, so the next one. ABC or the angles of a triangle ABC. Then what is this value? So what is given here? Here I am solving this one also in the verification method. Okay, see here. So what is given? ABC are the angles of the triangle. That is A plus B plus C is equal to 180. Now I am taking some angles ABC such that this condition holds, such that I am taking the angles like that. It satisfies this condition. So simply I am taking that the three values as A is equal to 60, B is equal to 60, C is equal to 60. That is I am taking here the triangle is the equilateral triangle. I consider this here, this triangle is the equilateral triangle. Okay. So this is sine 120. 2 into 60 120. This is sine 60. This is sine 60. Okay. And second row. This is also sine 60. And sine 120 and sine 60. Replacing the ABC is equal to 60, 60, 60 here. And this is sine 60 and sine A is equal to sine 60. And last value is equal to sine 120. Replacing ABC is equal to 60 is here. Now what is sine 120 value? Sine of 180 minus 60. Sine of 180 minus 60 is equal to again sine 60. Second quadrant, sine positive. So this becomes sine 60. So all values becomes here sine 60, sine 60, sine 60, sine 60. And second row is also equal to sine 60, sine 60, sine 60. And third row is also equal to sine 60, sine 60, sine 60. Now what is the answer to this question? Already we know one formula. If two rows are equal in any determinant, then the det value becomes 0 here. Okay. So here see here all rows are equal. First row is equal to second row, then the answer is equal to 0. Therefore the answer is equal to 0 and that is the second option. Okay. So this is the direct formula. If in any determinant value, if any two rows are equal, then the determinant value becomes the 0. Okay. Okay, so the next one, if det of x minus 2 whole square, x minus 1 whole square, x square, x minus 1 whole square, x square, x plus 1 whole square, x square, x plus 1 whole square, x plus 2 whole square is equal to, what is this value? Here also I am taking that x is equal to 0. I am replacing that x is equal to 1 here. I am replacing x is equal to 1 here in this question. So what it returns? 1 minus 2 whole square. Minus 1 whole square is equals to 1. 1 minus 1 whole square, 0. 1, this is 1 minus 1 whole square, 0, 1, 1 plus 1 whole square, 4, this is 1, this is 4, 1 plus 2, 3 square is equals to 9. You can take any of the values in place of 1 here. I am taking that x is equal to 1. So what is this answer? 9 minus 60 minus 7 minus 0 plus 1 of 0 minus 1 is equal to minus 1. Therefore the answer is minus 8. Of course we can replace any of the values here. You can take any values here in place of the x to get the answer. So here I am taking x is equal to 1. If suppose, again I am taking the second example also. If we take x is equal to 0. Now check the answer. 0 minus 2 whole square, 4. This is 1. This is 0. 1, 0. This is 1. And this equals to 0. This 1. This is 4. Okay, now finding the det value. 4 of 0 minus 1. Minus 1. Minus 1 of 4 minus 0. That is 4 and last value is 0. Answer is equal to minus 8. That is, you can take any of the values in place of the x and you will get the same answer for whatever the value of the x, you will get the same answer. Okay. So this is the answer and that is the third option. This is the processor. Okay, see the next one. Det of 0, p minus q, p minus r, q minus p, 0, q minus r minus p, r minus q, 0. We want the determinant of this matrix. Det of 0, p minus q, p minus r, q minus p, 0, q minus r minus p, r minus q, 0. What is the determinant value? Okay. In the next step, I am taking that this matrix as 0, p minus q, p minus r. Now here I am taking minus common. It becomes minus of p minus q. And here also I am taking minus common, minus of p minus r. This is 0, this is q minus r, and here also I am taking the minus common, minus of q minus r, 0. Now what is this one? Once check properly here, this is the skew symmetric matrix. All the diagonal elements are equal to 0 and these three values are positive values. The same values are existed below the diagonal with the negative signs. Okay. So this is the skew symmetric matrix. Therefore, det of the skew symmetric matrix of order is equal to 3 is equal to 0. Direct formula. Det of the skew symmetric matrix of order 3 of order odd order. Skew symmetric matrix of order 3 is equals to 0. So direct answer is equal to 0 and that is the second option. Okay, so this is the answer. Last question, 0 2005 2006 minus 2005 minus 2006 0 2007 minus 2007 0. Once observe here, this is also the skew symmetric matrix. These two elements are positive numbers, these two are the negative numbers. This is the negative one, this is the positive one. So clearly this is the skew symmetric matrix. So what is the example of the skew symmetric matrix? 0 0 0 1 2 3. Then what will be these three numbers? Minus 1 minus 2 minus 3. The matrix which is in this form is the skew symmetric matrix. Therefore, this is in the form of the skew symmetric matrix. So, answer is equal to 0. Det of the skew symmetric matrix is equal to 0. Therefore, answer is equal to 0. Okay, that's all. So, I will continue the remaining sums in the next video. Okay.